Hey everybody, and welcome to McCardle Math Academy. In this video we are going to be doing an example where we use integration by parts. But before we start, let's actually look at the formula for integration by parts. This may be a little different from some you've seen in some textbooks, but this is the one we'll use here. So this is just to remind you of what the form is. Now let's apply that form to this example here. So we have the integral of x to the fifth times ln of 2x with respect to x. So when we look at this integral, it's obviously that it doesn't fit into a basic formula that we have. Then we attempt to use substitution because that's generally the easier way to go. Whatever you make for a substitution in this integral, you will not have success. So that leads us to using the method of integration by parts. So in this method you have two things to do. You first have to choose what you want u and v prime to be from your original integrand. So here's our original integrand, and we're going to choose u and v prime. You have to learn from experience how to choose these things, but a good guideline is to set v prime equal to the most complicated part of the integrand for which we know the integral of. So ln we don't have a basic integral formula for, but we do have one for x to the fifth. So we're going to set v prime to be x to the fifth. All right. That then leaves the remainder of the integrand, ln of 2x, to be what we set our u to be. All right. So we see that we've gotten our integral now. If we make these substitutions, we've gotten our integral to be in the form u times v prime, all with respect to x, which remember was on the left side of the equation that we start with for integration by parts. So the next step after we make our choices is that we have to compute a couple things. So we're first going to compute u prime using the formula for u. That's a basic derivative. We get that it's 2 divided by 2x, which simplifies to just 1 divided by x. All right, and then we compute v using the formula for v prime. So to do this, we take the integral of v prime, which is x to the fifth, with respect to x. That's a very basic integral, so it's x to the sixth over 6. All right. Generally, you would have plus c in this case, but as we discussed in class, that's not necessary with this method. The plus c will come later on. So now we're going to come back up here and we're going to apply the rule. So I'm going to write the rule down here. It's u times v minus the integral of v times u prime, all with respect to x. And then we're just going to put in the pieces we know. First we put in u. Remember what we set u to be, that's ln of 2x. Then we multiply that by v, which is x to the sixth over 6. And we're going to subtract the integral of v, which is x to the sixth over 6, times u prime, which is 1 over x, all with respect to x. And again, all I'm doing here is I'm using the four things we know. We have u, v prime, u prime, and v, and I'm using those to fill out our equation for integration by parts. So we're going to simplify this. This simplifies to the first one. I'm just going to rewrite a little bit. And the second integral here becomes x to the fifth over 6, all with respect to x. Again, the whole point of integration by parts is that the integral we end up with down here is simpler than the one we started with in the beginning. All right, and it is in this case. So we finally compute that last integral, so we get x to the sixth ln of 2x over 6 minus, using the basic rule, x to the sixth over 6, but there's already a 6 there, so we end up with x to the sixth over 36. And this would be our final answer for this problem. as we know, we could take a derivative of that answer, take a derivative of this to make sure that we end up with what we started with. All right, I'll see you guys next time. Enjoy.